Okay, so this is a very straightforward question in which we have to find the definite integral of this given function 4x into sin x divided by 1 plus cos square x, right? So one thing you should notice is that whenever you get some algebraic function multiplied by trigonometric function, if you proceed using the methods which we have studied in indefinite integral, then you will have to use methods of by parts, right? But that will be a lengthy procedure. Instead of that, what we can do is, since this is a question of definite integral, we can use some standard properties that we know, right? So here, if I call this integral which I have to calculate as I, right, then I know one very good property here, that integral of fx dx from 0 to a is same as integral of f of a minus x dx from 0 to a, right? Okay, so if I use this property, my I value will also be equal to integral from 0 to pi 4 times of pi minus x into sine of pi minus x upon 1 plus cos square pi minus x, right? If I further simplify this, I will see that this equation now converts to integral of 0 to pi 4 times of pi minus x, let us keep it this way, and sine of pi minus x is again sin x. And if you look at the denominator, then because of this square term, it is still plus cos square x dx. Okay, so I now see two different equations. One is the original question, and second is the equation which we just arrived at, right? I would like to add these two equations. If I add equation 1 and 2, my LHS quantity will become 2 times of I, and RHS, since both have same limits from 0 to pi, I can combine the integrals. So from 0 to pi, if I add the quantities, I will have same denominator. So denominator will remain the same after taking LCM, 1 plus cos square x. And now numerator will become equal to 4x sin x plus 4 into pi minus x sin x dx. So in this case, my 4 sin x gets cancelled with 4 sin x, which I will get after opening this bracket. So let us cancel out this x. Okay, so I will be left with 4 pi sin x, right? From this quantity, I will get such equations like 2 times of I is equal to 4 pi integral from 0 to pi sin x dx divided by 1 plus cos square x, right? I have taken the constant quantity outside of the integral. Now after this, there is one very simple substitution, that if I use cos x is equal to t, then my minus sin x dx quantity should become equal to dt, which means that sin x dx should become equal to minus of dt, and I will get something like this. Let us cancel out this 2. So I will get I is equal to 2 pi integral of 0 to pi minus dt divided by 1 plus t square, right? Since I have changed my variable, let us also change the limits. When x is equal to 0, value of t will become equal to 1, and when x is equal to pi, value of t will become equal to minus 1, right? So I have to solve this simple integral now to get my answer. I can use one more property of definite integral here. So minus sign, this minus sign can be used to change upper limit and lower limit. So ultimately my I value will become equal to 2 pi into integral from minus 1 to 1 dt upon 1 plus t square. But 1 upon 1 plus t square is nothing but tan inverse of t, right? So it will become 2 pi into tan inverse t. Limits are from minus 1 to 1. On solving this, what will you get? You will get pi by 2, which on cancellation will become pi square. So your final answer is I is equal to pi square.